It's over to you, sir.
All right, perfect. So, hey guys, how are you all doing? I hope you all having a pretty good weekend. Give me a thumbs up in the chat if you are having a good weekend. Awesome, awesome. So let me not waste time. I've got just an hour, and I hope if you know me, you know that I talk a lot. So let me
Yeah.
start sharing my screen. Mhm. All right,
Yeah,
just let me
many
know if you can
people
see
are.
my screen. Yes.
Yes, it's visible, sir.
Okay, just a minute. Let me reshare the screen because I also have to keep a watch on the chat. So let me just share this one particular tab. Mhm. Perfect. I hope you guys are able to see. You're
Guys,
on
you
mute.
can comment.
Just let me know if the, what do we say, the screen is stuck or something like that. In between, I'll turn off my video for better latency. All right, perfect. So let's just get started. I just had this for basic AV check. So uh, let me straight up dive into the topic, guys. First of all, let's understand deep learning as it is. So um, it's pretty simple for you guys to simply Google and ChatGPT what is deep learning and see what exactly it is. But I want to know how you guys understand it. So um, anyone, just tell me in a single one-liner, like what exactly it is. Anyone. You can, are they allowed to turn on their mic?
Yes, sir, they are allowed to turn on their mics.
Okay, anyone, like can simply in just one line tell me what exactly it is. Not technically. Technically, it's pretty easy to know what deep learning is. Tell me how you guys understand. Anyone? Nikhil in the chat says neural networks. I would say no, because neural networks is not all about deep learning, but yeah, deep learning, sorry, the other way. Uh, Deep learning is not all about neural networks, but neural networks is all about deep learning. Subset of machine learning, yeah, correct. But no, give me a general example, guys. Machine learning by experience, yeah, you're getting close. Nice. Okay, cool. So let's learn that today, what exactly it is. So I'll give you a gist of what's going to happen today. I'll also give you hands-on. If time permits, we'll code together, or else I'll give you a nice demo. So first of all, why deep learning over general machine learning models? Then how exactly deep learning works? How exactly does a neural network predict? And we'll see how neurons and layers, all of that are formed. And this part is going to be pretty special because today I made a very nice demo for you, which I've never presented anywhere yet. I think it was only one place where I did. I'm going to replicate the human brain, completely show you how exactly the layers are formed, how exactly data is processed by making a map out of it. So let's see if that works out. So that's one thing. And then how to work with image data. So this is all about deep learning. Image data is all about deep learning. I hope you guys know. So that is about what we're going to do today. And before we start, before we go into the topic, do you guys know me or have you seen me earlier? If yes, give me a thumbs up. Or else you can put down in the chat where you have seen me earlier. Okay, so a lot of people who are seeing me for the first time, I hope I don't mess up today. I've got a reputation to handle. Okay, cool. For the people who have never seen me earlier, let me tell you what I am, what I do, and why exactly am I giving you this lecture today. What makes me worth sitting over here. That is this that I've been working for now more than 3 years. It's been, I think, around 4 plus years that I've been working into machine learning. and mobile app development. My primary area of expertise is quant. Of course, machine learning needs a lot of math. I hated math, and see where am I? I'm doing math for my living now. So that is where I am. I lead something called as TensorFlow User Groups Hyderabad. This is a Google-backed community for the AI and ML ecosystem. I'll give a short promo regarding it at the last. So this is what I am. This is what I do. And if you guys want to reach me out, you can use this endpoint. If you know how endpoint works, it goes after the domain slash whatever goes after the slash is called as an endpoint. If it is GitHub slash this endpoint, if it is LinkedIn slash the endpoint, it stays the same. Even for Instagram, it stays the same. So you can reach me out over there. Uh, so moving ahead, let us straight away get into the topic without wasting any time. First of all, let's understand why exactly deep learning is needed. But like, see, machine learning is there. It's doing its work. It's fine. We are able to get the job done. Why exactly deep learning comes into the picture? Anyone? Can anyone tell me why exactly deep learning comes into the picture? Why do we need uh, deep learning apart from machine learning? What can machine learning? Sorry. In what uh, area does machine learning lack so that we need deep? Anyone can either tell in the chat or simply can unmute and speak. Thinking by its own, that's pretty vague. Not see, even machine learning models think on its own. That's pretty vague. Try to what do we say? Specify what machine learning cannot do, what machine learning can do. Sorry, what machine learning cannot do, what deep learning can do. Working with large data, DL is used. Okay, uh, that is right. But tell me if what do we say? There is 1 GB of data set. If I'm trying to use a machine learning model, won't it work? Of course, it works. So large data, yes, you're right. But ML also works with large data. DL automatically learns. ML also automatically learns. Adding extra layers of parameters for the yes. Nikhil is right. Adding extra layers of parameters there. But I'm thinking of one answer which you guys are missing. One specific answer. Machine learning predicts where, as deep learning gives a perfect answer. Well, no, nothing gives a perfect answer. When you try to train your own model, at the end you will be getting all shit answers. Yes, that happens. But I mean, for the first time. Later again, when you train it multiple times, slowly you will feel proud of your model. Machine learning predicts the answer. That's almost. I'll just give a thumbs up to people who got it right. Machine learning requires manual feature. Exactly, feature extraction. Very, very right. So I'll just give it a 100. Machine learning predicts that perfect answer by thinking. I'm still confused. What does this mean? So extra layers of parameters. This is also right. Large data is also right, but not fully. All right, cool. So let me just directly dive into why exactly we need deep learning over machine learning. So first of all, guys, imagine a very simple thing. Um, let's say everybody is from Hyderabad. Give me a thumbs up, Hyderabadis. Give me a thumbs up, Hyderabad or Telangana or AP. Telugus, give me a thumbs up. Okay, let me take a bigger example, bigger area. So let's say um, your house is getting dirty day by day. Your mom or maid, whoever comes, grooming is becoming a headache. Every day morning grooming. So what do? Weekly once you mop it, right? Or else, what do? You go crazy. You simply throw out all of your what do we say bed and all out of the house. You simply put a pipe and wash it off. So this is where deep learning comes in the picture because ML doesn't work perfectly in some places. Those places are, I'll tell you, one is image. ML doesn't work with image data. So let's just see step by step, like what exactly. happens. So first of all, ML does not work that well with complex patterns. That is why I told image data. So tomorrow, let's say if what do we say, you're sitting in an interview, don't simply tell him that this mop and broom example. Tell that ML does not work good with complex data. So it doesn't work with complex data. For example, image. Images are complex. They have a lot of pixels in them. Each pixel has a different color. So that is like a mess. So it doesn't work that well with complex data. That is why we need something like an upgrade, like I told. You need to deep clean your house when normal clean doesn't work. That is why we need to go a bit deeper, analyze the data. So that is where deep learning comes in the picture. Then easy to leverage huge data sets, of course. ML also can leverage huge data sets. Yes, but deep learning is something where it is easier, where the models are much handy. They can, what do we say, easily do it. So also just a quick check. My voice is fine. No disturbance.
Yes, sir, it's fine.
Okay, cool. Let me just turn off my camera for better latency. Cool. So let me continue. It's easy to leverage use case. And then what does deep learning models handle, which machine learning models don't do? Pretty simple. It handles a lot of unstructured data, just like your mom handles your tantrums, very smooth. So that is exactly why deep learning could work with image data, complex patterns, complex structured data, or maybe completely unstructured data, while machine learning cannot. So let's take one simple example of a machine learning model, linear regression. It's pretty famous. Um, in linear regression, what do? You give properly structured data, like this data is the x variable, that data is the y variable, and then we put on test data out of sample data and do the prediction. So that is way too much structured. Even a kid can see the data and tell that, okay, this is the prediction. You don't need a what do we say model for that. While coming to deep learning, it is accepting much unstructured data, which is not straightforward. It is like all clumsy. For example, an image. What data can you extract from an image? There can be tons of data, right? There can be objects, there can be, what do we say, different colors, structures, uh, contours, a lot of different things. So that is where deep learning comes into the picture. So the people who were researching on ML were like, no, we need something more better. Then they came up with deep learning. So basically, machine learning on steroids is deep learning because it goes deep. So moving ahead, I'll simply sum this up with one, what do we say, paragraph. Basically, this is deep learning is something where we are replicating the behavior of how actually humans learn. For example, by looking at data, by splitting them into parts. Let's say we see something, our mind first analyzes, okay, this is of this color, this is of what do we say, this structure. Then our brain makes up an image that, okay, this is how it is. For example, imagine someone who in life has never seen something called as a green apple. Suddenly you give him a green apple and he'll be like, what the fuck is this? He'll be like, this is not an apple, this is a pear, or maybe this is something else. uh, then when his mind sees that green apple somewhere else, then he realizes, okay, this is an apple but in green color. So that is how even our brain learns. Our brain segments stuff, understands stuff, it analyzes, and then it learns. Just like a kid, just like you guys, uh, go to the same class 10 times and you're not able to learn, and then you do one night batting one YouTube video 10 times, then you learn. So that is how it is. See something in what do we say, in so many structured formats, in so many different what do we say, types of parameters, that you learn it. That is where our layers are formed in deep learning, which we'll explore further. I'll try to also show you how those layers are formed. So that is exactly where the word deep comes from, so that we go deep into it, we analyze it deeply, and extract patterns from it, analyze patterns from it. That is where it is called as deep learning. So moving ahead, if I simply Google it, how do, first of all, let's not go to neural networks directly. First, I want to ask you guys, tell me any famous model, any generic model that comes to your mind when I say machine learning, not deep learning, machine learning. I'll also put down in the chat. Everybody don't say linear regression, say something else. Any ML model. And just put it down in the chat. You can put it down in the chat or decision tree. Yes, correct. SVM, support vector, right, you're right. Any other types of regressions other than naive Bayes? Yes, you're correct. KNN, you're right. Clustering, you're right. Okay, so now I'll ask a question. That's fine. You guys are giving right answers. Random forest, that is right. So you guys are giving right answers. Now understand all of these models from one perspective. That all of these models don't go on only one type of data. They are for different types of data. Let's say you have properly structured data which is somewhere in linear format. For example, you're predicting uh, tomorrow's price of something. Let's say tomorrow's stock price or gold price or whatever. Then you use a linear model. Why? Because you are predicting a linear, what do we say, variable. Then if you're predicting class type variables, then something like clustering or some class type model comes. So it is all dependent on data. And what do we say? Let's say you're doing uh, analysis on some series of data, some sequences of data, then you use something called as time series. So for different types of data, different scenarios, there are different ML models. Now, whenever we say deep learning, everybody says only one model, that is neural networks. Why so? Why neural networks is like just the one famous basic model that sums up machine deep learning itself? Any answer for that? Why neural networks is the base of every single thing in deep learning? When you simply Google what do we say deep learning models, you'll get the basic four things. You'll get uh, recurrent neural networks, you'll get what do we say different types of neural networks, basically convolutional neural networks. But the base of everything, the neural network is there. Why so? Mm, like a schema for DL? Yes. Nikhil, you're almost correct, 90% correct. Guys, the answer is right on your screen. The answer is on screen. Why? Because summing up, deep learning is simply replicating the behavior of human brain. That's it. And what is the best thing that can replicate? What is the base thing that can replicate the human brain? That is a neural network. Exactly. Right answer, Mohammad Yasser, Mukesh Reddy. Both of you have given right answers. Just like brain, it analyzes. And Mohammad has said layered structures that mimic the human brain. Correct. Nikhil, Yasser, and Mukesh, right answers. So just like the brain, it is, mimicking the patterns. So that is exactly why neural networks is completely the base, or what do we say, the bastion of deep learning. And further on, neural networks are again, what do we say, optimized. They are made better based on the type of data, the type of application, and made into convolutional different other neural networks. And then on top of that, we have GNs and all. So moving ahead, first of all, how does a neural network work? Simply, this is a screenshot I've taken from Google. Simply, if I ask Google, Google says that neural networks work by mimicking the human brain by structure and function, using interconnected nodes to process information, learn patterns of data, etc., etc. All of this random stuff it gives, which even we are not able to understand, which even our human brain is not able to understand. Why? Because first of all, we never know how our brain internally works, right? We never studied, what do we say, psychology or maybe neuroscience to learn how the brain works. So let us see in you know a high level, what do we say, from a high level view, that how exactly we learn things. Firstly, we see some things, analyze it, and then we try to recollect it. That is how a basic human brain function works. We see something, let's say, we saw a beautiful girl. Our brain says, go ask her number, right? So this is how the brain functions. Now, if we see a bodybuilder guy behind it, immediately the brain analyzes again and says, no, this is too risky, right? So this is how it gets. Then what happens? This is not just for once, right? It happens multiple times in a loop. There's not simply like the brain started at point A, ended at point B like a function. Correct. What does a function do? It starts at point A, ends at point B, returns some value, that's it. Its work is done. But the brain is not like that. It is continuously looking at things, evaluating things, stuff which you are not able to understand. It is a, like, what do we say, reiterating on things. So just like that, how a neural network works is it structures things in such a way that it evaluates multiple times. It does not just once look at something, take a picture, feed it in the brain, and simply write a if condition that if this matches this, throw true. It's not like that, right? So for suppose, let's say, you took picture of a leaf. If this leaf matches this leaf, return true. That is not how your brain function works, right? It sees a leaf. There are millions of types of leaves, and it understands, okay, this is how a leaf is. And how does that happen? By structuring it completely. It structures it and takes out some parameters. It takes an input and then subdivides it multiple times until it properly understands it. That is how a neural network works. So now let me tell you the technical part of it. Let me just give a time check. Yeah, it's 6:30. I'll just give you one technical part of it and then go into a bit of math. Uh, so guys, put really, what do we say, your keen attention over here, because if you don't understand this, you'll not understand anything. First of all, whatever a neural network and a neuron in your real brain sees, they first segment in the sense, basically analyze it completely. As you can see here, there is a leaf. Completely, it has what do we say, taken a grid or something, analyzed it pixel by pixel, analyze it pixel by pixel, and taken it as input. Correct. Now, there is one hidden layer where it is subdividing it. Correct. It is subdividing it and it is sending all these inputs to for further analysis, for further, feature extraction, for further, parameter analysis that, okay, this is a leaf. This looks like this. This part of the leaf looks like this. This is how it is. It is in green color, etc., etc. Until all of these, what do we say, uh, layers are properly have extracted feature, come to a consensus that yes, this is how a leaf looks like, and there comes your output where what do we say, your leaf, the image of a leaf is formed pixel by pixel. So this is how your brain works. This is how your what do we say neural network works? Pretty simple. Like um, by hearting a theorem or maybe by hearting a what do we say theory written by some big scientist which we don't understand. What we do, firstly we try to read it all of at once and try to put it in our mind. It doesn't work. Then we break it down. Then we try to understand it in parts by parts. We break it down. We reiterate it multiple times, one by one, and then it works. So that is exactly how neural network works. Now let's go a bit deep into it. So first of all, neural network has what we say five major important things. One is the input layer, which you also saw over here. This is the input layer. This is where it takes some inputs, like what do we say, be it image, text, whatever it is. Um, it completely what do we say is fed through this layer, through the input layer, and the input layer can have n number of nodes. It can have one, two till n. It can have n number of nodes. Through these nodes to a neural network, this particular input is fed, and further on, these layers are made, which are called as hidden layers. Now, these layers can be decided by two things: one, the user; two, by the model itself. But usually, when we make a neural network, we decide how many hidden layers should be there. So, for what do we say, some small applications, we take uh, hardly 3 or 4 layers. That will be enough. Now, moving on. mm, what do these hidden layers do? As you can see here, through a series of layers, the network performs mathematical operations, etc., etc. But uh, some, like in easy words, simply it takes this input, sees what exactly it is. Just like I told the theorem example, it breaks it down. What exactly it is trying to see. Again, breaks it down further, breaks it down further. So it understands that okay, this is how it is. This is how it is. Let's take sample of some random image. Let's take the image of a dog. It sees that okay, this particular dog has these kind of eyes, these kind of ears. Uh, so it further on, pixel by pixel, pattern by pattern, contour by contour, or, understands it, tries to understand it. Okay, so let's also try to play a small game. I hope you guys like dogs. Everyone, give me a thumbs up if you do. Okay, so I'll tell you the type of the dog. Put your neural network to work and tell me what kind of dog it is. So I'll just give you the description, okay? If the dog has completely white in color and has black spots on it, what dog it is? White in color, black spots. You guys can also, unmute and speak. A dog is completely white in color and has black spots on it. What dog it is? Guys, no need to type. You can unmute and speak. Let's have a nice discussion. Amulya, even you can participate.
Yes, sir, I'll be participating.
So is it okay? Maybe should I fine tune it? Dalmatian, yes, you're right, Deepak. Dalmatian, yes, correct. White dog with black spots, or in simple words, Richie Rich dog. So Dalmatian. Okay, if a dog looks like a wolf, it has a wolf looks, nice fur,
Husky.
exactly husky. And what if a dog has golden fur? Usually is fat and lazy also. Golden fur, golden fur usually is fat and healthy and also is lazy. Golden retriever. You guys have anyone? Anyone has a retriever? No? Okay. So Just imagine the reason why I played this dog game is um, there are, you know, millions of dogs. How exactly you were able to find out that, okay, this is a Dalmatian, this is a Husky, this is a Golden Retriever? That is exactly what deep learning does. So now coming back to our leaf example, see what is exactly happening here. It is segmenting the image pixel by pixel and understanding, okay, this is how a leaf looks like. This is how a dog or a cat looks like. So that whenever we feed an image, it checks it pixel by pixel, extracts features from it. So another important thing over here in uh, machine learning, we extract features manually. Uh, let's say something like if you are predicting a disease, we decide what is the risk factor, uh, what should go how, and what should be the BP, etc. And all of these things we take it manually, the parameters. Here it happens automatically. Uh, for example, the eyes of the dog, the face, how it is, the fur, etc. In like let's say if it is a leaf, how thick is the leaf, how bright is its color, etc. Just like that. So let's move further. Just give this one a good read. I'll just keep it for a minute and then we'll move forward. So okay, I think I stopped this in between till hidden layers. So I'll just continue it. Meanwhile, you guys can also read. You need not worry about this data and all. I'll share this with the organizers. I think with Ravi or Amulya, I'll share the content required so that they can share it with you. Quick time check. The time. Yeah, we do have time. So yeah, like I was telling, all those uh, quite detailed parameters like the eyes, the contours, how exactly what do we say, the data in the sense the image is structured, this pixel has what kind of data, all of these things happen inside, and these nodes communicate with each other and then further on pass on the data, so that completely this is the image is learned. So let's say this particular layer might learn that, okay, uh, this might be the color, this might be the texture. Then further on something more complex will be learned, like, okay, even in the texture this is this type of texture, even in the color this is this type of color. More, what do we say, fine tuning, more fine tuning, more fine tuning. It happens over the layers until it reaches one single output. So and then the output layer is formed exactly like the input layer. The output layer is also formed, which also can have n number of nodes, which finally gives us the final input, that the from the given input values, what kind of what do we say, output is classified as what. So and then again there is prediction. What prediction is not basically a layer, it is something that we find out. The class or basically the output with the highest probability is chosen as the perfect prediction. So let's code this. Let's try to code this on Kaggle. I hope you all have Kaggle accounts. If not, try to go to simply kaggle.com and try to code it along with me. So I'll also try to give you the notebook link so that you can code along with me. How much time do we have? We have enough time. No worries. Okay, perfect. Are you able to see the code screen?
Yes, sir, it's clear.
Perfect, perfect. So I've also shared the Kaggle notebook link in the chat. Can I pin it? How can I pin it? Yeah, done. I've pinned it as well. Also, guys, a small request. If you like this notebook, just give it an upvote. This is called as an upvote. You can just simply click this and give it an upvote. So this is the demo I've prepared for neural networks. Let me simply try to run it and show you how it works. So here, basically, what I'm trying to do is um, predict the category of a flower. instead of a dog or something, I'll take a flower, which is a very famous what do we say data set. Anyone who starts their machine learning or deep learning journey, they definitely know that uh, there is a data set called as iris data set, and one flower has three different types based on the length of the flower, the size of the flower. So how many of you have already worked with it? Give me a thumbs up, or let's do one thing, let's put flower in the chat. If you have worked with iris data set, put a flower in the chat. Yes, I have worked. I'll put a flower. Okay, some guy typed flower and then typed the flower again. Okay, perfect. Since you guys have already worked with iris dataset, I'll again, for the people who uh, don't know what it is, I'll reiterate over here. Simply, whoops, 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 not yet dear. I'll simply write down one more thing here. In iris dataset, we have um, different types of iris flowers. So just like we discussed, dog is the same thing. Okay, just like we discussed now, dog is the same class, but it has types like husky or Dalmatian, retriever. So just like that, similarly, iris is a single flower of which has different breeds, different types. Breeds will look much vague, different types, and we will try to predict. We'll try to predict the type. Done. All right. So this is what we are trying to do, and here we'll first of all import the necessary libraries. For simulating deep learning, we need something called as uh, Keras and Scalars and also TensorFlow. Uh, Here, basically, I'm using Keras. sklearn we are using for train test split. Also, I'll tell you that basics as well. Some basics. This is markdown. This is markdown. How can I convert this into markdown? Let's push it. I delete this. Yeah. So first we take a data set. Just because we don't have the test data, just because we don't have real time data, we take 30% or 20% of the data set, of the current data set, to test our model, or say make predictions. Got it. For this we need to use something called as TTS, train test split. TTS from sklearn. Learn, yeah, which is called as train test split. So 70% will be used for training, 30% of the data set will be used for testing. So pandas is for what do we say, handling what data set, basically 2D data. For that is why we use pandas. NumPy is numerical Python used NumPy for handling math stuff and all. And coming to the important thing of deep learning, here it is. We are using Keras. From Keras, we are using something called as sequential. Sequential is something that provides us with neural networks. So I'm a big fan of Keras because it is like revolutionizing deep learning world. It has got pretty insane models. So uh, I'm not telling because it is Google's product, and I advocate for Google AI technologies. That Keras is open source, so it has got pretty good things comparatively to PyTorch and other things. It is really good. Go try it out. Um, and especially after the latest update, after Keras 3, it has got some really good features where you can seamlessly integrate your models with a backend API, even if it is in JS or something else. So moving ahead, sequential is something that provides us with our deep neural network. Oops, I'll note this down as well. Sequential provides us neural network, and dense provides the density, like how much dense the neural network should be, how many hidden layers should be there. So that is where dense comes in. And for data visualization, we have plot model, matplotlib, cbon, etc., etc., the usual stuff. And instead of manually downloading the data set, uploading the data set, I'm a lazy guy, so I just simply import a data set from sklearn. I just do a datasets.load iris. That's it. The data set is loaded. So we need not download it, have it in local, again upload it over here. We need not do that. So if you guys are sick of what do we say, downloading data sets and using them from your local or something, check out these two things. One is TFDF data sets. I'm putting it, uh, we call it TFDFs, or else simply try TensorFlow data sets. And TensorFlow data sets, there is sklearn. You can try importing data sets from sklearn. From sklearn, import data sets. You can try doing this. There are a lot of really interesting dataset providing libraries which give you a very nice data set. Simply what you can do is you can call the library and you can load your model, sorry, you can load your data set from there. So I'll simply run this once so that all my dependencies are installed. Yep, they are installed. Now I'll try to load my data set. It's running. Yeah, it did. Let's see what all is there in the data set. Yeah, here you go. Now as you can see, guys, I want you to pay some attention over here. This is how our dataset looks like. It has got sepal length, width, petal length, width. If you have gone to school, you know what sepal length, not length, sepal petal is. Basically, petals are the colored part of the flower, and below the petals, you've got sepals, the greenish part, which is a bit hard. Uh, Usually which doesn't come in your camera photos. So that is sepal. Basically, the top colorful, beautiful looking part, sepal. The bottom part, which is attached to the stalk and all, that's the petal. So based on the width of it, based on the size of it, we will determine the species. So basically here in this data set, I just have seen the data set. I just did a df.head. Df.head gives me first five, or else let me do df.head 10. It will now give me first 10 elements of the data set. So as you can see, if the sepal length is this much, width is this much, petal length is this much, width is this much, this belongs to the species called as setosa. And I'll do a df tail, which will give me the last 10 elements of the data set. The species is something else. Why the sepal length width is different over here? So basically, there are mixed of all kinds of iris flowers in the data set. As you can see, I've written here, this data set is like a mix of all kinds of iris flowers. And our aim is to classify the different species based on the features. And what are our features over here? The length, width of sepals and petals. Just like what do we say we did for our dogs and So this is a very straightforward, simple example, yet effective. Let's try to do that. So firstly, what I'll do is I'll split the features and the target. Oh, wait a minute. Is this deep learning part? Yeah, yes, it is using sequential. So yeah, it is deep learning. Yep. So firstly, I'll spread split this data set into features and target. First of all, guys, tell me why are we splitting this into features and target? Anyone? Whoever is giving me the right answer, I'll try to give you a TensorFlow sticker whenever I come to Hyderabad. If we meet in any of our meetups, why do we split into uh, target and features? Question repeat. I'll simply put down the question over here. Why do we split the data set into target set and feature set before making the predictions, or else before training simply? Done. This is the question. I've put it in the chat. Why do we split the data set into target set and feature set before training? No chat GPT answers, please. Because we split the data set to separate input from the target. Wait, I'll get it. We split the data set to separate input features from the target output for prediction. Why? Why do we do it? The question is why. Of course, we split it. I only told we are splitting it. But why do we do it? X as an input and Y as an output, cause Y is dependent on X features. Exactly. Nikhil got the right answer. So Nikhil, drop down your email, maybe in personal chat or somewhere, or simply send your email to, I'll try to give you a e-badge or something. And whenever we meet, I'll give you a sticker. Praneet says maybe to get accuracy. Absolutely not. This is the funniest answer I've got today. This has no relation with accuracy. So basically, guys, XR is something that is, what do we say, our input, and Y is the output. Ramya says to avoid overfitting. No, madam, this is not at all related to overfitting. Not at all. I don't give it a wrong. Train the model to predict target based on input features. Yasser is also right, but you missed one point. That is uh, because see, something should be dependent on something so that that one relation will come out. For example, let's say you take a car. Your car is dependent on petrol. Only then you will be able to predict how much petrol will your what do we say, car uh, charge you for this much distance, right? If for that your car should be dependent on petrol. Simply, if your car is of petrol and you're predicting how much CNG will it cost, it's wrong, right? So basically, X and Y are variables. I'll tell you. Very simple. I think you learned it in school, or maybe what do you call it, junior college, 11th, 12th. X and Y. X is what? Features. Y is the target. If we not say it in machine learning terms, ML terms, X is inputs, Y is the output. Got it. So all of these, sepal length, sepal width, petal length, these are the inputs. These are X labels. And Y, as you can see, setosa, versicolor, virginica, all of these are the outputs. We are simply predicting, what do we say, Y equals mx plus c. If we do regression, if we do linear regression, we are simply doing this, y equals mx plus c, and we are finding y. This is one case where we are not finding x always. Sorry, bad meme reference. So this is where we are finding the target. Okay, What is our target? What is our prediction? Of course, what is the type of the flower, right? So simply what we do, we split the type of the flower. We split what is dependent, the X features, the features of it. We train with the features, we train with the target, and then we train the model in such a case that, see, these are the features for which this is the target. Got it? Just like that. So this is how training goes. Be it any model, any model. Um, these are something, very, very basic, that you guys have to be very strong at these, even especially if you are going for machine learning roles, maybe in your job, data science roles, or maybe for internships. You have to be very strong at these, because when the interviewer asks you this, you will know, but you won't be confident. That will get screwed later. When you come and google it, you'll be like, array shit, it was this, and I knew it. So you have to be very strong at this. Simply, what is X? Features. What is Y? Target. Why are we doing? We are fucking predicting Y. That is why we are doing it. Simple. It is dependent. Okay. Simply, I you guys also learned it in school, right? That uh, in Y equals mx plus c, tell me which is the dependent variable and which is the independent. Y is, okay, I'm running out of time. Let me quickly tell that. Y represents the dependent variable. Y output is always dependent on something. Like I told, how much petrol does your car charge? Your car is dependent on petrol, right? So even now, the target, the type of iris flower is dependent on what? Dependent on the features. What is the sepal length, what is the petal length. Just like what do we say, we played the dogs game, right? The type of dog, it was dependent on what? The features of the dog. How is the dog? Uh, the color of it, etc., etc. So this is the whole AI game. This is the whole machine learning game. What are the features, the parameters, and how we are extracting them, how we are playing around with them. Uh, See, simply imagine that one image can have how many parameters? Millions. But they should be unique. Each parameter should be unique. For example, apple is a fruit. How many parameters it can have? Taste is one parameter. Uh, Color is one parameter. Size is one parameter. It should be unique. So even the LLMs, how they are made, they are huge, lots of parameters. Billions of parameters are put together. Then the model is trained for reaching one target variable. That's the whole game. So once, if you get really good at this basic engineering part, then you're going to ace it. So let me just quickly go forward. So what we are doing, I'm simply splitting it. I'll simply split my features from my what do we say, target variable. So I'll run this. I'll simply split it. I got my features. And simply if I try to print Y, it will give me all the outputs of my current training data set, not testing data set. We split already. We did a split here. We already did the splitting somewhere. Where is it? Where is it? I think we didn't yet. Yeah, we didn't do it yet. So it basically gave me all the targets. As you can see, three types: setosa is of one type, this versicolor is of one type of iris, and then virginica, this is of one type of iris. So basically there are three types of iris flowers. It gave me the target, and it also gave me a long list of features. So now I'm going to train my model. I'm going to train my neural network, think that, okay, if somebody throws an iris on your face, uh, this is what you have to check. So basic visualization, to see how, what do we say, the data is. So by seeing that, this, what do we understand? We see if the sepal length is small, it is setosa. If it is medium, it is versicolor. If the sepal length is very high, then it is virginica, something like that. Also for the petals, if the petals are small, it is setosa. If it is medium, it is somewhere in versicolor. If it is if the petal width is very much, then it is virginica. So this is what we come to know by doing this basic analysis, very basic analysis. Now imagine this happening for images. It becomes really complex. That is where deep learning comes in. So now we do a simple encoding because all of this data is understandable to me, but it's not understandable to a machine. So a machine takes Virginica as a string, so it will take each as a unique string. So because as you can see, it's giving object type. So we simply encode it. We simply tell the machine that see, all of these are of the same type. Now it encodes it and makes it of the same type. So we did a nice encoding to it, and now we split the data. Our data is ready now. We got some insights out of it. We split the data, and now we are calling our neural network. We are calling our neural network. We are building a sequential model. We'll build it, and we'll try to make some cool predictions out of it. So let me first line by line explain what it does. First of all, um, we had a input layer, right? So here I'm taking input layer with 10 nodes, input layer with 10 units on X train. What is our X train? Features of the training data set, not the testing. Testing data set, we use it for prediction. Okay. And then I'll take one hidden layer with 8 nodes. And then we are taking one output layer with 3 nodes. Why? Basically, I saw here that there are three different types of outputs. Three different types of outputs, 0, 1, and 2. So I'm taking 3 nodes. That is what my data analysis gave me. So just to, what do we say, simulate the neural network, simulate a neuron, I'm taking a layer, input layer, one hidden layer. I can take 3, 4, 5, 10 also, but it's not needed. It's a simple data set. So one is enough with 8 units, and 8 units means basically 8 nodes, and a output layer with 3 units, basically 3 nodes. Each node will give me one out. Got it? Pretty simple. Now, to compile this model, basically machine learning models don't need compilation. Neural networks do need. So I'll use a very, what do we say, common compiler, Adam. That's an optimizer. So I'll explain this compilation part later, uh, because I'm running out of time. I've got around hardly 3 minutes left. So we'll compile it. I'll try to run this part. Oh, perfect. It ran. Now, coming to this part. This is where we just built a model. We just built a model. And I hope you guys understood how did we make, and I think in your mind you were able to make up how this neural network is going to look like, um, with 10 inputs. Just simply visualize it. 10 input nodes, layer 1, 8, layer 2, 3, layer 3. Got it? So with the 10 nodes, 8 nodes, 3 nodes. So this is how our model is. Now what we'll do is take all this data, dump it onto this model, simply throw it on its face and tell that get trained. So I earlier trained it on to 50 epochs, but I don't have that much time. I'll do it for 25 now. Also, guys, anyone, what are epochs? I'll simply put it in the chat. What epoch means. I kept it in the chat. Quickly, guys. Okay, until this runs, I'll first start running this one. Until this runs. Ah, pretty quick. Thank God it didn't give up on me. Usually it happens slowly. Any answers? No answers yet. Okay, so I'll tell you what epoch means. So basically, let's say um, I did model.fit, which means I'm training the model once with X train and Y train data, which is the features and labels of the training data. I trained the model once. That is one epoch. I trained the model again with the same data, or with like different data added to it, or whatever it is. I trained the model again. That is epoch number 2. So what is the reason why train the model multiple times again and again? It's because it should get familiarized with it, so that there is no scope of error. The model learns perfectly. That is why we do something called as epochs. We train it multiple times. Now, with the same data, we have trained this model which we made 25 times. So as you can see, epoch 1 started. It gave me some accuracy also. It also gave me some loss, how much loss happened. And as you can see, as the epochs went further, the accuracy increased and the loss decreased. The loss was 1.7 earlier. It was pretty high. And the accuracy was very less, 0.00 something, basically zero accuracy. And slowly it increased to somewhere like it increased to 0.3, then the loss decreased to 1.0, and slowly it increased to 0.7, then the loss decreased to zero point 0.8. From 1.0 it went to zero point 0.8. Now the loss is zero point 0.8, which is acceptable, and the accuracy is zero point 0.6. So if we simply increase the epochs to 50, the accuracy will become much better. So that is why we use epochs. And then I'll just try to plot this model. There's basically just a plot. I'll tell you how this plot works. First of all, we took the first layer, input shape. Uh, Wait a minute. How much time do we have? It's 7:10. Can I extend it for 10 minutes? Amulya or Ravi? Anyone?
Yes, so you can.
Okay. So audience, are you fine? Give me a thumbs up. Should I keep going?
Guys, comment.
Yes. Okay. Cool. I just wanted one yes. I was desperately waiting for one yes. Okay. Awesome. So I'll just keep going. So I have simply, whatever model we made, I simply plotted it. I made a plot kind of thing. So I'll try to decrease the this thing and show you. Yep. So as you can see, this basically this is the shape of the model. This is the shape of the model. We took 10 what do we say, input units, and then we had 8 hidden layers. Then we took 3 what do we say, output units. So first, it started with 4, went to 10, then that 10 came here in the first layer, then it went to 8 in the second layer, then this 8 went to 3. So this is how it works. So the input layer started from here, it went further, it went further, it went further, came out. So this is how our model got plotted, and I'll just try to increase it more. Yeah. Now let's also check the accuracy quickly because our model should be good. It should not be worst. Okay, the accuracy is still getting printed. Okay, fine. The test accuracy we got on test data, not what do we say, training data. Model training data's work is done. We trained the model. The model got trained. That is fine. Now we need to test it. So on test data, I just ran something called as model.evaluate, and I just printed the accuracy. So we've got 0.7, which means 70% accuracy. 0.7 doesn't mean that 0.7%. It is 70% accuracy, which is enough, pretty good, not that good as well. So we can train it on more epochs to get a better accuracy. Now what I'll do is try to make predictions. What our model has predicted. So what I'll do is I'll take X test. I won't give it Y test. Why? Because Y is the, what do we say, uh, the answer to the question that I'm asking. X is the feature, X is the question. So I'll simply store it in a variable, and what we'll do is take the original Y predictions data, and the compared Y predictions data, the sorry, Y test, Y, I'll take the Y test data and Y predictions data and try to compare it. How accurately is this able to compare? So that comparison, I'm doing it here. As you can see, I'm taking Y test and Y prediction classes and making a matrix. So then it will be able to show me how much accurate is this. So as you can see, uh, for actual Setosa values, it predicted 10 out of 10, and it did not predict wrong values like this. So here is Setosa. I'll show you. I'll zoom it out. See, this is Setosa, this is Setosa. This block has 10, so, and the other blocks have 0 0. So this predicted well. But when coming to versicolor, it predicted two right values. And for what do we say, others, it predicted seven, which is wrong. So here it went a bit wrong. And for Virginica, 11 out of 11, it worked well. It didn't predict, what do we say, Virginica as Setosa, Virginica as some other class. So this was fine. But here it got messed up. As you can see, here also it should have been completely dark with zero over here. But it didn't do well over this particular region. So we need to again train it with more epochs, mm, pump this accuracy to 0.9, 90% accuracy, and test it again, and then we'll get a better confusion matrix. So that is how neural network works. Now, coming to the most important part that I promised, um, that we will visualize this particular model that we made. Which model it is? This particular model, our neural network. And I'll try to make a sketch out of it. Let's see if it works or not. Where is it? Yeah. So for this, I'm using a library called as Network X, which basically makes a network. It is kind of a drawing library. I'll run this. I've tested it already. It is working. So I've taken my same model with 10, 8, and 3 nodes in 3 layers, over 3 layers. Layer 1 has 10, layer 2 has 8, layer 3 has 3. I'll simply run the same model. And now this is a kind of function which is drawing nodes. As you can see, it's having a for loop to draw nodes. Again, it will draw the other nodes, etc. It will give color. So I need not explain this. I'll simply run this. Ta-da! Here is our tree. So this is how our current model looks like. It looks pretty fine to me because it has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank God. And 1, 2, 3, 4, 5, 6, 7, 8. Fine with three output uh, nodes, which is pretty fine. So we've got a pretty decent model over here, and I've got notes for you so that you guys can check it out. And here I have made a simple, what do we say, regression model also so that we can compare it. But let's not take it right now. You guys are already tired with lots of theory, I think. So I'll simply share this particular notebook in the chat. I've already shared it. I'll share it again so that you guys can go try it out, or maybe add some changes to it, make it better. I'll pin it in the chat. Also, guys, do give it an upvote if you like it. So let me quickly get back to my presentation. Where is the PPT? Yeah. So the code is done. I'll simply sum it up. So summing up, guys, what we did is pretty simple, straightforward thing. We took a data set and which had basically three different classes. We used a neural network to predict those classes. And what does a neural network do is it picks up all the data, segments it into very, very fine sub parameters, resegments it again over the hidden layers, and then gives you a nice fine output. So to save time, I summed up it very quick. I'll also try to give you a few notes apart from this. The organizers will share it with you. And this is the generic roadmap that I'll usually suggest. Also, my screen is presenting, right? Any problems over there? Fine. You
No.
are able to see the roadmap. So this is what I generally suggest when someone wants to learn deep learning. First of all, get very good with theory. Theory is really, really important. If you're implementing naive Bayes, you first need to learn what naive Bayes algorithm is. Why is it actually used? Then you can go further on into code and then implement it. So get very well versed with theory, learn neural networks. After neural networks, go deep into model architecture. What particularly a neural network does, how it is internally, like how we saw, how does data flow through it, all of that stuff, and then build your own models, then try to optimize the code, try to make it much faster, much efficient, much accurate. You can use a lot of tools over it. You can use TensorFlow, Keras, you can take any other tool, and this, should keep iterating. The learning should not stop, and you have to keep again starting. Like, let's say you've done with basic neural networks, then again start learning recurrent neural networks theory, convolutional neural networks theory, then try to model it, then try to build it. This should keep iterating. So as developers, we are iterators. We don't go exponentially, we keep iterating. So that is it from my side. Before ending, a very, very short promo, like I told, that I run a community called as TensorFlow User Groups. We do a lot of meetups, knowledge sharing events, hackathons, where we have got industry experts, Google developer experts certified, and we have a lot of diversity, inclusivity, promotion, and a lot of cool stuff. So we are driven by a lot of geeks who are very, very enthusiastic about AI, very, very enthusiastic about building products with AI or leveraging products with AI. So if you really want to join it, I'll share a quick QR. You can scan it up and join the community. And whenever we have an event, um, you will get notified. So that's it from my side. If you This is the same QR. If you have got any questions, you can unmute and speak, or you can simply put it down in the chat.
Guys, share your questions in the chat box.
Okay, if you guys don't have
Then,
questions, we can wrap it up. Also, if you have any questions, you have got the QR, you can scan it up. There's a specific uh, forum for question and answers over there on our communal page. You can put your questions there. There are a lot of seasoned expert uh, who will be very happy to help you out. So if you want, you can join us, and that's it. Thank you so much for having me. I hope you guys enjoyed it. Special thanks to Ravi and Amulya. You have been a very good host for tonight, and Slate Valley has been doing a very good job, guys. Follow them, keep promoting them. This is a very young platform, seen by very young people. Do what do we say? Promote them in all sorts of ways.
Yeah,
More
so
power
thank
to
you
you guys.
so much, sir, for a powerful session on deep learning. Truly inspiring and engaging. Students
Thank
have they are saying lot of thank you in the chat box. They have no questions, but they have thanks for you. It was then truly engaging, sir. I think they have been enjoyed the session a lot.
Yeah, sure, guys. Do keep everyone in the loop. If you want more such sessions, trouble Ravi.
thank you, Moin, for joining today. Like,